Hello, this is KP the Math G. I've got a little time while my wife is sleeping a little bit, napping. I was going to do a video. So, here we are. We're doing part 2. We're determining concavity and points of inflection from this function g here, 3x squared minus x cubed. In the last lesson, what we did was that we looked at this from a perspective of looking or examining each graph. We graphed g, we graphed g prime at x, and then we graphed g double prime of x, noting that, well, when we graphed g at x, then we saw exactly what the graph is doing, where it's increasing, where it's decreasing, where the concavities are, where the point of inflection is, and so on. But from g prime, we could tell exactly where g is increasing or decreasing. It kind of confirms it is what it does. So we know for a fact that if we didn't draw the picture of g prime at x, then or g at x rather, if we didn't draw this picture here, then or graph it rather, then we could still figure out where g is increasing or decreasing by the first derivative, and then by the second derivative we could find out points of inflection, or even and actually, if you have a point of inflection, you definitely have concavity. And just keep in mind what a point of inflection is. It's something like this, and to the left of this point of, and actually I always use the x value of the point of inflection. So if x is equal to a, so if this is say a comma b, then that point of inflection means that to the left of x equals a, you have the second derivative is positive. It's positive because we see that the graph is concave up. And so if g double prime of x is greater than 0, we know that g on this interval here is, and I like to say CC, concave up. Alright, and here we see that there is a change in sign. In other words, this g double prime at x is positive, but here on this side, if g double prime x is less than 0 or negative, then g is concave down, and it's concave down on this interval. To the left of x equals a, concave up. To the right of x equals a, concave down. And that's the idea. That's what we're leading to. X equals a is a point of inflection, a point of inflection. And that's kind of what we're leaning toward at this point in the graph. Now see, again, I don't want to draw the picture of the graph, but I do want to show you, without drawing the picture, we can still find out the behavior of g by finding both g prime and g double prime. So let's dive in and look at g prime first. I know we're talking about g double prime when we talk about concavity, but at first we want to look at increasing and decreasing right now. Where is g prime increasing or decreasing? So here we go. G prime is 6x minus 3x squared. And what we want to do is we want to find that horizontal tangent, because, you know, that is where on this graph here, this is where g is increasing or decreasing. All right, so let's do that. Okay. All right, so let's see right here. It actually means the slope of the tangent line. The slope is 0, okay, at that point. Alright, so 6x minus 3x squared. Now, I do want to factor out, to solve for x, I want to factor out 3x in this case. Let's see, so if I factor out 3x, I'm going to get 2 minus x, okay? Alright, 3x times 2 is 6x, 3x times x is 3x squared. It's got a minus sign in the middle. Okay, so now a times b equals 0, meaning that 3x equals 0, or 2 minus x equals 0. If 3x is equal to 0, then we know that x also is equal to 0. Or in this case, if 2 minus x is 0, I can just move the minus x on the other side and make it positive x. So 2 equals x, x equals 2. These are what we call critical points right here, okay? And this is where we find also our maxes and our minimums. So not only do we figure out where g is increasing or decreasing, but we also find out where the maxes and mins are. Alright, so let's take a look at this, just looking at this portion right here. What I want to do here is I want to plot these critical points here, 0 and 2. Now this divides this up into 3 areas, or 3 intervals, if you will. One interval is from negative infinity to 0. Alright. Another one is from 0 to 2. And then another interval is from 2 to positive infinity. Okay, just like that. Now, let's pick a number somewhere in this interval. We're just going to pick negative 1 in this first one. And then on the next one, we're just simply going to pick 1. And on the third one here, we're going to pick, say, 3. Alright, so we're going to do each one of these one at a time with this here. Okay? So here's what we got is, so we're looking at g prime at negative 1, and that's equal to 3 times negative 1 times 2 minus negative 1. Now, I'm going to give the answer on the first one, but we're not really interested in the answer. What we're interested in is what is going to be the sign of this. We know that 3 times negative 1 is negative 3, and 2 minus negative 1 is 2 plus 1, which is positive 3, and the answer is negative 9. Again, we're not concerned that that's negative 9. All we're concerned about is that this answer is negative. Well, what does that mean here? Alright, so in this interval here, all these values from negative infinity to 0 are negative. Alright, that means that g is decreasing. G is decreasing on this interval, that's what you want to say, from negative infinity to 0. So you're going to have to say what's happening, and you're going to have to say on what interval it's happening. Okay. I guess my wife didn't realize that my leg is stuck in there like that. So anyway, sorry about the camera shaking. Let me double check to see that everything is still okay. Oh, yeah, we did move a little bit. Okay. Let me. Okay, I gotta get this on. Okay. I tried to get as much space back as I could so I could get the whole picture. Okay, so bear with me just a little bit here. Alright, it's going to be okay, everybody. Sorry. Okay, the deal is my man cave here is adjacent to the bathroom door, and when my wife got up, she shut the door on my leg here, and it moved the camera. So I apologize for that, And that's what she and I were talking about just now. Okay, back to the show. This is negative, which means you need to show both of these. G is decreasing, and it doesn't mean that, yeah, G is decreasing on this interval. You might want to say on the interval. Alright, so we have G decreasing, okay? Alright, so let's take a look again. I want to do G prime at 1. Alright, so now we're looking at the interval from 0 to 2. Okay, G prime at 1. Alright, so here we go. 3 times 1 times 2 minus 1. Okay. Alright, we know that this is 3 times 1 is 3, and that's positive. And then 2 minus 1 is 1, and that's positive. And positive times positive is positive. So up here, that's positive. You can't just leave it like this. You got to say what G is doing. Not G prime. G prime determines what G is doing. Okay? Just like G double prime determines what G is doing as well. Alright, so G is, this function right here, is increasing, on this interval between 0 and 2. Okay, then finally, G at 3. And you think about it. If you put 1,000 in there or 1,000,000 in there, you know that everything's going to be, well, we don't know yet. Let's see what happens. I got to remember, that's 2 minus that. So, okay. Whew. All right, so 3 times 3 times 2 minus 3. So if you had 2 minus 1,000, you know that's going to be negative. We know this is positive. Positive times a negative is negative. So now we understand that on this interval we have a negative, which means that G is decreasing on that interval there. Okay? That's what we have. Alright. And that is just G prime. Now remember, we're looking for concavity and points of inflection, but we did G prime so that we could get to G double prime. Okay, so you have to do G prime first. You don't necessarily have to analyze this. I'm going to erase this because we really don't need it at this point now. Alright, that's basically it. And what I'd like to do this time is we're going to do G double prime and set it equal to 0 too. Alright. Alright. And the reason we want to set that one equal to 0 is that, well, we want to find the possible point of inflection. And actually, you can find it from G prime. It's going to have a, okay, so anyway, you'll see it on that. Incidentally, if we were to just draw this graph, and I said I wasn't going to do this, but here's the illustration here. What we have is 0, and we have 2 right here. And I'm looking at the graph here. I already graphed it ahead of time, and I noticed that the graph is doing something like this here. Here's X, here's Y, and it's doing something of this nature here. It's coming down, and you notice it is decreasing, and then it's going to come up a little ways up, and then from there it's going to just drop down like that. And that's the idea of this. Okay, it's doing just that. Okay, so we know that from negative infinity to 0, G is decreasing. Between 0 and 2, G is increasing. This is decreasing, this is increasing, and then from 2 to positive infinity, we have G decreasing once again. Okay, so that's the idea behind F prime. Decreasing, increasing. Also, we also know that this is a minimum at 0, at x equals 0, and we have a max at x equals 2. Alright, like that. Okay. Well, okay, that's the idea. And, okay. I guess I should have left this up because I do want to talk about that point of inflection again, but that's okay. Alright, here we go. G double prime. This is what we've been wanting to get to for a while now. Okay, so G double prime. Now, let's see, we've got to take the derivative of G prime. So that's going to be 6 minus 6x. If we set this equal to 0, we have 6 minus 6x equal to 0. We can just move this over here. 6x is equal to 6, and what do we find here? This is 1. So what do we mean when we found 1 here? Well, this means that this is a possible point of inflection. So let me show you again what a possible point of inflection looks like. That would be that right there. Okay, so if this is A right here, if x equals A, then of course, well, we would have to have a point, so maybe we'd call this the y value would be B. Alright, so at A comma B we have a point of inflection, which means that it's going to divide. It kind of comes as an in-between point for, the change of concavity. So we have so we're looking at concave up here from the left of x equals A. So in this case, we're saying that G double prime of x is greater than 0. That means that, okay, it's positive. We're going to have concave up. Alright. In this particular case, G double prime at x is less than 0. That means it's negative, which then that means then to the right of A, from A to positive infinity, we have G being concave down. Concave down. Okay. All right, and that's the basic idea behind the point of inflection. X equals A. That's not actually the point, but that's the x value of the point of inflection. Okay. All right. So that's the idea behind that. All right. Just to kind of give you an idea of concavity. Now here's what we're going to do here. On this one, I'm going to draw a different picture right here. And I still want to put, I'm going to put 1 right here. Since this is our only possible, point of inflection here. Okay, this divides this up into 2 areas. Negative infinity to 1. Okay, and then 1 to positive infinity. Okay. Alright, so there it is again. So it wouldn't hurt that if you were doing this, that you would find where your possible point of inflection is. Well, first of all, what I'm saying is, it wouldn't hurt that you would label your intervals. Okay, write your intervals down. In interval notation, I do it in interval notation. Okay, so all right. So let's see here. Let's pick 0 here, and then let's pick 2 right here. And this time we're plugging it into this problem right here. So let's see. We have G double prime at 0 equals 6 minus 6 times 0, which again, all we're looking for is whether it's positive or whether it's negative. and we have 6 plus 0, which is 6, and 6 is positive. So therefore, in this interval, we have the positive value here, and then so we say that G is concave up on this interval right here. Okay, G is concave up. All right, and then right here, obviously, we want to look for, now, if 1 is a point of inflection, then G better not be concave up on this side, because if it's concave up on both sides, then we don't have a point of inflection. If it's concave down on both sides, we don't have a point of inflection. Okay, but here's where the signs must change. So let's try it here. G double prime at 2, we have 6 minus 6 times 2, which is 6 minus 12, which is negative. And that's what we wanted here. So this one is negative here. All right, and so we have G is concave down on this interval from 1 to positive infinity. And once again, I mean, so that's what we had to do. To get to this, if you're just looking for concavity, you can just skip out. You don't have to evaluate G prime like I just did. But I did it to try to help you out to understand that you're looking for increasing and decreasing. Where is G increasing and decreasing? Here you're looking for concavity and possible points of inflection. And in this case, we only have one point of inflection. And one more time, okay, remember what the graph looked like last time. I wish now, well, I did need to erase it. All right, the graph, okay, so here's 0, and then here's 2, and I'm going to go ahead and put 1 right here. The graph did something like this. It went down to 0, coming right here, and then it curved upward like here, and then it went. So it increased from 0 to 2, just like we found a while ago. And then from here it went down like this. Alright, so what we have here, we had from the first derivative, our max is at x equals 2 and our minimum is at x equals 0. And then what we're finding here is that place of concavity, right? I mean, this is actually the point of inflection here. Okay, and that's what we're looking at. X equals 1. Now, we could plug that 1 into this value here. G at 1 would be 3 times 1 squared minus 1 cubed, which is just, this is 1, so 3 times 1 is 3, 1 cubed is 1, so 2. So right here at 1 comma, well, we would have to, I want to say that's 1 comma 2. Let me look that up just to make sure that I did that correctly. Bear with me just for a little bit. Okay, let's see. At 1, well, it's saying 3, and I'm trying to think why it says 3. Let's see. Okay, yes, and yeah, okay, that's right. Yeah, that is correct. It is 2 right there. So at 1, the value is 2. So at 1 comma 2 then is the point of inflection. All right, if you just want the x value, it's x equals 1. Okay. If you need the point of inflection, then you gotta, after you find that 1, you gotta plug it back into the original problem, and then you find the y value. Okay. All right, there it is. And again, just understand that not everything has a point of inflection. And again, to make sure you have a point of inflection, you must have concavity going, well, it can start off being down, but in this case it's up, concave up, okay, and then concave down. Okay, and so that's what we're talking about. There needs to be a sign change, in other words. Positive, F G double prime is positive, G double prime is negative here. It could start off negative and positive. It doesn't matter, but there needs to be a sign change. Alright, so that's kind of what we're talking about here, and that is that. This is signing off with KP, the Math G. Hopefully you have a great day. Thank you so much for being patient. Have a good day.